For section 5.5, we're going to talk about bases other than e. Now, we have been talking about derivatives and integrals of lots of different functions throughout the year. And so today we're going to talk about derivatives and integrals if the base is not e or x. So we are used to like x squared or x cubed or x to the fourth power. When this is x, we have our own rule. It's the power rule. It's very simple. If your base is not x, your base is a number like 2 or 3. So for example, this would be, you can look down here, like 2 to the 3x. These are called exponential functions because the x, or the variable, is in the exponent, versus a polynomial function would be like x is the base and then the number is in the exponent. So that's what we're doing here, is exponential functions, because the x is in the exponent. You can look here. And the base is a real number, like 2 or 3 or 4. So I've got some rules. We'll go through the rules for the derivatives that we'll do. We'll go through the rules of the integral that we're going to look at, and then we'll apply them to these 5 examples. These are really just formulas that you'll have to be able to read and apply to different derivatives or different functions that we're going to take the derivative of. So the rule up here is if you want to take the derivative of a real number with an exponent, that's a function, something with an x, it's kind of like multiplying 3 different things together. The first thing is ln of the base, which here it's a. Then you'll multiply by just copying whatever that is. And last, you will multiply by the derivative of u, which is your exponent. I'll show you how to do that in example 1. The derivative, if you have log of some real base of some function, that is going to also be 3 parts, but it's going to be 1 over natural log of a times, still on the bottom, u times the derivative of u. I wrote them kind of separate there so you could just see the 3 separate things, but all of that would get multiplied together. The integral rule is 1 over natural log of a times copying a to the x and then plus c. This will also work with u and du if we get to that point, and we will. I'll show you 2 examples where it will be u and du. But those are the 3 formulas. Let's do an example. So first we have take the derivative of 2 to the 3x. So this is a real number with a function exponent. So we're looking at this formula right here. So 1, 2, 3 things we have to multiply. First is ln of a, that's ln of the base. So the base here is 2. So the derivative would be ln of 2 times. Copy the whole thing. So copy 2 to the 3x times the derivative of u, use the exponent's 3x, so the derivative would be 3. Because this 2 has an exponent and these bases aren't the same, you cannot combine those. This is a number out in front that's multiplied, and this, so I am going to write the 3 out in front of everything. 3 ln of 2, put that in parentheses, and then times 2 to the 3x. You don't want this ln of 2 and that 2 to, melt together, so I do keep my constant, which is 3 ln of 2 in parentheses, and then my 2 to the 3x is just multiplied there on the end. Let's do another one. Can you see all those? Okay, so derivative of log, no base, so base 10 of cosine of x. So now we're looking at this rule. It starts with 1 over natural log of the base. Our base here, it was an invisible 10, so I made it visible. So we're going to start with 1 over natural log of 10. On the bottom of that fraction, you multiply by u. U is the piece getting logged. So the piece getting logged here is cosine of x. Last, multiply by the derivative of u, which is the derivative of cosine of x, which would be negative sine of x. You have a couple different ways that you can write this when you're done. You can slide that over and multiply it by 1. So this would be a great way to write it. That is natural log of x, or natural log of 10, sorry. This would be 1. If you see those trig identities and you're like, oh, I remember sine of x over cosine of x is tangent of x, you can replace sine of x over cosine of x with tangent of x and make it negative tan of x over natural log of 10, and that would be even better but not required.